Hello, good morning everyone. This is D. Chinnagokari. I am going to explain about atomic models in this lecture. In previous lectures, I have given brief introduction of atomic structure and what is chemistry and what it deals, and also classification of matter. I have explained about classification of matter, and I discussed discovery of subatomic particles and their charge, specific charge, and also I have explained about properties of electron, proton and neutron. Now in this lecture I am going to discuss about atomic models. See, what is atomic model? We already know atom can be divided. So when you divide the atom, you will get the subatomic particles or fundamental particles. There are mainly three fundamental particles are there. They are electron, proton and neutron. So now atomic model is nothing but so these are going to discuss how these subatomic particles are arranged in the atom. So what is the definition of atomic model here? The systematic arrangement of subatomic particles in the atom, that is called what? Atomic model. So there are several atomic models are there, like Thomson atomic model, Rutherford atomic model, Bohr's atomic model, Sommerfeld atomic model, and also quantum mechanical model. And each and every model, they are trying to explain how these subatomic particles are arranged in the atom. So in each and every model we have some important points. So they told something about the atom, even though some failures are there, but we can extract all these points, we can summarize the total atomic models. Now let us discuss about atomic models. The first atomic model is given by J.J. Thomson. We already know J.J. Thomson discovered the electrons, and also he got the Nobel Prize in chemistry for the discovery of electrons. Right? According to Thomson, atoms are having spherical shape, spherical sphere like cricket ball, volleyball, and the total positive charge is spread throughout the atom. So like here you can observe that like blue color is spread here throughout this atom, and the electrons are embedded inside the atom more or less uniformly. So here the size of the atom is 10 to the power of minus 10 meters. The size of atom 10 to the power of minus 10 meters. And here he said that there are equal number of protons and electrons are there inside the atom. That's why the atoms are electrically neutral. So here, so according to Thomson, atoms are spherical in shape. The size of the atom is 10 to the power of minus 10 meters, and size of the atom, and the total positive charge, total positive charge, that is nothing but protons spread throughout the atom, and the electrons are embedded in it. These are the electrons are embedded in the positive charge. Okay. So here Thomson is able to explain the electrical neutrality of the atom. Why? Because there is a equal number of protons and equal number of electrons are present in the atom, so that he can able to explain the electrical neutrality of atom, but he failed to explain the stability of atom. According to some electrical theories here, whenever a positive charge and a negative charge, they are in the direct contact, they are going to cancel out with each other, and there should be no electron, no proton in the atom. But still we are going to find out electrons and protons inside the atom, which proves that this model whatever it may be, it failed to explain the stability of atom. Why? Because according to Thomson, both protons and electrons are present in the means they are they are in the direct contact in the atom, so that they should cancel out with each other, but it is not happening, right? Next we have one another model, that is Rutherford atomic model. So Rutherford atomic model, let us discuss about Rutherford atomic model. Before he proposing his atomic model, he performed one experiment. So that is alpha ray scattering experiment. Alpha ray scattering. Alpha ray scattering experiment. So he performed this experiment to verify the Thomson atomic model. He verified why he performed this atomic model, this alpha ray scattering experiment, to verify the Thomson atomic model. See here, alpha ray means, what is the alpha ray? Alpha ray here, helium with a double positive charge, that is called here alpha ray. So by doing this experiment, he verified the Thomson atomic model, right? So here, what are the experimental setup in the Rutherford alpha ray scattering experiment? He performed this experiment along with his research scholars Ernest Marsden and Geiger. Marsden and Geiger are given support to this Rutherford to perform this experiment. So now let us see what are the experimental setup in the Rutherford alpha ray scattering experiment. That is, he took one alpha ray source, one radioactive element which emits the alpha particles, He allowed to fall these alpha particles on a thin gold foil through a lead plate. So this lead plate allows only in the straight line, monochrome straight line, and he allowed to fall these alpha rays on the thin gold foil, thickness of 100 nanometers. Why he used only gold foil? Because this gold is highly malleable, which means we already know malleability means making into thin sheets. Here we can convert gold into very thin sheet. So we can do this experiment very easily. That's why he used only gold foil, and moreover the gold is unreactive. When you see in the electrochemical series, gold is very unreactive. It is in the last in the electrochemical series, and he arranged a fluorescent screen around this gold foil, so to observe or to detect these alpha particles. To track the path of these alpha particles, he arranged a fluorescent screen which is made up of with zinc sulfide. Okay. So now this is the experimental setup in the Rutherford atomic model. First he did alpha ray scattering experiment, so to verify the Thomson atomic model. So here he performed alpha ray scattering experiment. So here alpha ray is nothing but helium with double positive charge. So this is the experimental setup in the alpha ray scattering experiment. So here he took one alpha ray source. So this is alpha ray source, which releases the alpha rays, and he allowed to fall these alpha rays on the gold foil through a slit of lead plate, which can make these alpha rays into a straight line, and these alpha rays are going to fall on the gold foil, and he is going to track this path of these alpha rays by using a zinc sulfide screen. So here whenever these alpha rays are going to hit this zinc sulfide screen, it gives some glow. We already know that. So now what are the observations made by this Rutherford by doing this experiment? So here in his experiment he observed that, so most of the, let us consider this is the one of the gold atom. So the most of the alpha particles are passing through the gold foil without any deviation in the path, without any deviation in the path. They are traveling through the gold foil, they are passing through the gold foil without any deviation. They are moving in a straight line without any deviation. They are passing through the gold foil. So how he is going to say that they are moving in the straight line without any deviation? Means, see, here he is observing some glow on this zinc sulfide screen. They are hitting to the zinc sulfide screen and they are going to give some glow. Hence he concluded that, so most of the alpha particles, 95% of the alpha particles, 99% is of alpha particles passing through the gold foil without any deflection from their path. And what is the second observation here he made? Only few of the alpha particles are deflecting from their path with slight angles. Few of the alpha particles are deflecting from their path with slight angles, and 1 in 20,000 alpha particle. 1 in 20,000 alpha particles exactly bouncing back. So these are the observations made by the Rutherford in the alpha ray scattering experiment. So now let us see what are the observations he made. Observations. What are the observations he made in this alpha ray scattering experiment? So 95% of alpha particles. 95% of alpha particles passing through the gold foil, passing through gold foil without any deflection. Without any deflection. Next, few of the alpha particles deflecting with a slight angle. Few of alpha particles deflecting with a slight angle, and 1 in 20,000 alpha particles. 1 in 20,000 alpha particles exactly bouncing back. So third observation, 1 in 20,000 alpha particles exactly bouncing back. Exactly bouncing back with 180-degree angle. With 180-degree angle. So these are the observations made by the Rutherford by doing this alpha ray scattering experiment. And what are the conclusions given by the Rutherford? Conclusions. What are the conclusions? Conclusions given by Rutherford. Conclusions given by Rutherford. Conclusions or simply conclusions given by Rutherford. So he said that atom has 95%, approximately 95% atom has empty space. empty space. Means neither they are repelling or neither they are attracting here only, but they are neither they are nor they are attracting, neither they are repelling with the gold foil, but they are passing through the gold foil. So if Thomson is true, so according to Thomson we already know atom is spherical in shape and the total positive charge is present in the center of the atom. Total positive charge is spread throughout the atom. According to Thomson, the total positive charge is spread throughout the atom, but most of the alpha particles are passing through the gold foil without any deflection. So if Thomson is correct means, so according to we already know Thomson atomic model, so the total positive charge spread throughout the atom. Is it or not like this? So let us see here only, let us assume. So let us assume this is the Thomson atom, means according to him the total positive charge spread throughout the atom. But here alpha particles are also having positive charge. If it is true, the alpha particles should get reflection here and they should bounce back. Why? Because alpha particles are also having positive charge. According to Thomson also the total positive charge is spread throughout the atom, so that we already know like particles repels with each other. So here because of this positive charge they should bounce back, but in the alpha ray scattering experiment they are not bouncing back, they are passing through the gold foil, which means there is nothing present in all this space. Why? How we can say that? So most of these alpha particles are passing through the gold foil. Most of the alpha particles are passing through the gold foil without any deflection. Most of the alpha particles are passing through the gold foil without any deflection. But if Thomson is correct means this should come back. Why? Because they should experience repulsion, then they should come back, but they are not coming back, they are passing through the gold foil, which means 95% atom has empty space. And and again he said that one more conclusion, the total positive charge present at the center of the atom, the total positive charge is located at the center of the atom. So this is called nucleus. This is called nucleus. So nucleus is discovered by Rutherford by doing which experiment? Alpha ray scattering experiment. How he is saying that the nucleus, that the total positive charge is located at the center of the atom, means these alpha particles are, some of the alpha particles are deflecting from slight angles, which means they are reflecting some slight repulsions. That's why they are deflecting from their path. And 1 in 20,000 alpha particles. See here, 1 in 20,000 alpha particles exactly bouncing back without any deflection. Exactly bouncing back without any deflection. So he said that, he concluded that the total positive charge is present at the center of the atom. So it is the second conclusion he given, the total positive charge present in the center of the atom is called nucleus. So these are the conclusions of the Rutherford, and this is the Rutherford alpha ray scattering experiment. Now let us discuss about what is Rutherford atomic model. So after this alpha ray scattering experiment, he proposed his atomic model. So note down. So now let us discuss about the postulates of the Rutherford atomic model. So here what are the postulates, means the important points about the Rutherford atomic model. So Rutherford, after doing this alpha ray scattering experiment, Rutherford proposed his atomic model. So according to Rutherford, also atoms are spherical in shape, and the total positive charge is present at the center of the atom. This is called nucleus, and the size of the atom is 10 power minus 10 meters, and size of atom and size of the nucleus, that is 10 power minus 15 meters. Size of nucleus, size of the atom is 10 power minus 10 meters, and the size of the nucleus is 10 power minus 15 meters. So when you compare to the size of the atom, size of the nucleus is very small in the atom. Size of the atom is very small. Size of the nucleus is very small in the, when you compare to the atom. Here the size of the atom is a 10 power. Size of atom 10 power 5 times greater than the size of nucleus, right? So how we can assume this? See, let us consider a cricket ball and a stadium, or a cricket ball is placed in the center point, and the 5 kilometers radius around that cricket ball is the size of the atom. In this way we can assume the size of the atom and the size of the nucleus, and electrons revolve around the nucleus. Revolve around the nucleus in a circular orbits. Electrons revolve around the nucleus in the circular orbits. How the planets revolve around the sun. Here also electrons revolve around the nucleus in the circular paths. These circular paths are called orbits. These circular paths are called orbits. So here in an atom, the number of electrons is equal to the number of protons, and that's why the atoms are electrically neutral according to this Rutherford. And here we already know these electrons are having negative charge, and the protons are having positive charge. So the electrons are having negative charge and protons are having positive charge. And how they are maintaining, how they are not attracting or how they are not falling in the nucleus, means they are experiencing two type of forces here. One is centripetal force and another one is Coulombic force. So Coulombic forces brings the electrons towards the nucleus, and whereas centrifugal forces bring the electrons, so means they throw the electrons far away to the nucleus. So on this electron, two type of forces are acting. So one is the Coulombic forces. So here Coulombic force, and centrifugal force. Coulombic force and centrifugal force. Coulombic forces and centrifugal forces. So Coulombic forces, because of the Coulombic forces, electrons are attracted towards the nucleus, and due to the centrifugal forces they are moving away from this nucleus. Here in an atom, both Coulomb forces are equal to the, means the amount of Coulomb force equal to the amount of centrifugal force according to this Rutherford. That's why the electrons are not falling in the nucleus. In this way, the atoms are getting stability. These are some important points in the Rutherford atomic model. So according to Rutherford, so atoms are having spherical shape, and the total positive charge is present in the center of the atom, that is called nucleus, and the size of the atom is 10 to the power of minus 10 meters, and the size of the nucleus is 10 to the power of minus 15 meters. And what is the difference between the size of the atom and the size of the nucleus? Here, the size of the atom is 10 power 5 times greater than the size of the nucleus, and here number of protons present in the nucleus is equal to number of electrons revolving around the nucleus. That's why the atoms are electrically neutral. And how these electrons are not falling? How these electrons are revolving in a continuous position in the circular orbit means there are two type of forces are act as in these revolving electron. One is Coulombic force, another one is centrifugal force. Coulombic forces are bring the electrons towards the nucleus, whereas centrifugal forces are throw the electrons far away to the nucleus. There is a balance between the Coulombic forces and the centrifugal forces. That's why the electrons are continuously revolving in the circular paths. These circular paths are called orbits, according to this Rutherford. So these are the main important points in the Rutherford atomic model. Next, coming to the merits of the Rutherford atomic model. Rutherford discovered the nucleus inside the atom by doing alpha ray scattering experiment. By doing what? Alpha ray scattering experiment. He discovered the nucleus inside the atom, and somewhat he tried to give more explanation when he compared to the Thomson atomic model. But this Rutherford atomic model is also having some errors here. According to electromagnetic theory, which was proposed by the James Maxwell, according to electromagnetic theory, which was proposed by James Maxwell, EMR, electromagnetic theory, which is proposed by James Maxwell. When a charged body rotates around another charged body, so this when this charged body rotates around another this charged body, so there is this charged body continuously accelerates. This charged body continuously accelerates due to its circular motion. Due to its circular motion, this charged body continuously accelerates. So we already know when this electron is here, electron is having negative charge and proton is having positive charge. See here we can get one doubt, sir. See, the planets are also revolving around the nucleus, around the sun. Is it or not? Planets are also revolving around the sun. But why the planets are not falling in the sun? Why? Because they follow the Kepler laws, and there are some centripetal force and centrifugal forces are present on that revolving planets, and moreover the planets are not a charged body. But when you come into the electrons are charged bodies. Electrons are charged bodies. So these electrons, when they revolve around the nucleus, around this nucleus means this is another charged body. When a charged body rotates around another charged body, it continuously accelerates. Why it is accelerates here? Because change in direction. For each and every moment, the electron is going to change its direction. Electron is going to change its direction so that it should accelerate compulsory. Why? Because this is not a linear momentum. This is a angular momentum. So when it is want to revolve in angular momentum, and when you want to move in a angularly, it should change its direction for each and every time. So hence it accelerates. When it is accelerating, it is going to lose its energy in the form of radiation. And no longer it is revolving in the circular path, but it revolves in the spiral path. Spirals like this spiral. by making this spiral path, and ultimately it should fall in the nucleus. It should fall in the nucleus, and when it fall in the nucleus, and it will take how much time according to this electromagnetic theory of James Maxwell? It will take only 10 to the power of minus 8 seconds. This much time only it will take to fall in the nucleus. See, second only is very less time, but in the second how many parts? 10 to the power of 8 parts means it is very less time, and in that very less time only the charged body should fall in the nucleus, which means electrons should fall in the nucleus, but it is not falling in the nucleus. How we can say why? Because still we are going to find out electrons and protons in the atom, but if it fall in the nucleus we can find the electrons and protons. Cannot. Why? Because they are going to cancel out and there will be no electron and no proton. Hence we can say Thomson Rutherford atomic model also is having some defects. So what are the defects? So it is not explained with the stability of atom according to the electromagnetic theory which was proposed by the James Maxwell, and failed to explain means these are the demerits. Failed to explain. It failed to explain stability of atom. It failed to explain stability of atom, and so if it lose energy continuously, we should get continuous spectrum. But when you take the spectrum of these atoms or the molecules, we are not getting continuous spectrum, but we are getting the discontinuous spectrum. What is this spectrum? I will explain in the next classes. So here we are getting discontinuous spectrum, which means it failed to explain. It failed to explain. It failed to explain spectrum. It failed to explain the spectrum. Right? So these are the some failures in the Rutherford atomic model. So now let us summarize it. What is the Rutherford atomic model? Rutherford atomic model is nothing but so what is important postulate here? So that is important points. According to Rutherford, atoms are again they are spherical in shape. The total positive charge present in the center of the atom. Electrons revolve around the nucleus. Nucleus in circular paths. That circular paths are called orbits. And the size of the atom is 10 to the power of minus 10 meters, and whereas the size of the nucleus is 10 to the power of minus 15 meters. Size of the atom is 10 to the power of minus times greater than the size of the nucleus. So here how these electrons are maintaining the balance here in between the nucleus and the electron? Because two type of forces. What are the two type of forces here? Coulombic forces and centrifugal forces. Coulombic forces bring the electrons toward the nucleus, which means positive charge, whereas the centrifugal forces they bring the electrons away from the nucleus. Here both Coulombic forces and centrifugal forces are equal in between the electron and the proton. That's why they are continuously revolving in the orbits. And this just resembles like the solar system. That's why this is also called what? A planetary model. Planetary model or solar model. So these are the important points in the Rutherford atomic model. And what are the failures? What are the defects in the Rutherford atomic model? So according to electromagnetic theory, which was proposed by James Maxwell, when a charged body rotates around another charged body, it is no longer revolving a circular path. Why? Because when it is revolving in a circular path, when it is revolving around another charged body, it continuously accelerates due to change in the direction, due to circular motion, due to angular momentum. It is going to change its direction continuously, so that it should get accelerate and it should lose its energy in the form of radiation, and it should revolve in the circular path instead of spiral path. And when it revolves in the spiral path, ultimately it reaches to the nucleus and it will fall in the nucleus and they should cancel out. each other, but it is not happening in the atom. Why? Because still we are going to find out electrons and protons in the atom. It means it is failed to explain the stability of atom, it failed to explain the spectra. Okay. So this is about Rutherford atomic model, and tell us important points and what are the defects. We cannot. So this is about Rutherford. Okay. So in the next lecture, I am going to discuss about nature of radiation or nature of light. Okay. Thank you.